Okay, AP Statistics students, so here's another worked out example of a chi-square goodness of fit test. Slightly different than the M&M one, but still very much like it. Security officials at a casino are concerned that an unfair die has found its way into the building. Don't know how that would happen. They confiscate the die and proceed to roll it 96 times. The table shows how many times each value was rolled. Is there evidence that this die is truly unfair? Well, they rolled it a total of 96 times, got a 1 30 times out of 96, a 2 12 times, a 3 16 times, a 4 9 times, a 5 7 times, and a 6 22 times. Okay, well, what we need to do is talk about getting these expected counts. Well, when I roll a die, wouldn't I expect each value to be equally likely if the die is fair? So in other words, I would expect to roll a 1/6 of the time. Oh, but wait a minute. I'd expect to roll a 2 1/6 at a time, and a 3, and a 4, and a 5, and a 6. I would expect each die, each time I rolled, to get each value 16 times. So every now and then you're going to encounter a problem where logic tells you all of the expected counts would be the same. So now if you want to, pause the video and get a new observed list and an expected list ready to go, and then press play when you're ready to go. So I'm going to say my null hypothesis is the distribution of each outcome is what's expected. So what could I say? I could say the distribution of rolls or outcomes, maybe the distributions of outcomes 1 through 6 is equal to 1/6 of the rolls for each outcome. Any way that you want to say that basically each outcome is what was expected. And then the alternative hypothesis is the distribution of the outcomes is not equal to ... Okay, now that's the hypotheses, that's the state. Okay, the plan. Okay, well, what do we have to say for the plan? All of the expected counts are greater than or equal to 5 and randomness or 10%. Well, we don't know whether these dice rolls were randomly chosen from a big pile of dice rolls, so why don't we invoke the 10% rule? 96 rolls of this die is probably less than or equal to 10% of all of the times this die was rolled. And then, as we can see, all of the expected counts are greater than or equal to 5. Love checking the conditions for the chi-square goodness of fit. Real sweet and simple. Okay, we're ready to run the test. We've got our table. So now we need to play the game. Chi-square equals. We're certainly not going to do it by hand. Show them the first observed minus expected squared divided by expected, and then just go plus ... plus the last one, 22 minus 16 squared over 16. And then we're going to let the calculator tell us what that actually comes out to be. Degrees of freedom just happens to be 6 minus 1 again, so the degrees of freedom is 5 by happenstance. And then what else do we show besides chi-square and the degrees of freedom? We want to show a picture of a skewed right distribution, and as soon as we know chi-squared, we'll label that and we'll tell what this p-value is. So I'm grabbing my calculator and I'm pressing Menu, Statistics, Statistics Tests, chi-squared GOF down there at number 7. My observed list, I'm gonna tell it where it is. And then my expected list, I'm going to tell them where my expecteds are. And then I'm going to tell it my degrees of freedom is once again 5 and press OK. This time it's telling me that the p-value is 0.0003 with a little bit of rounding. Okay, and it's telling me that chi-square equals 23.625. Boy, that's huge. Don't worry about that too much, but it's a big number. We'll talk about what that number means in class. Okay, well, it seems to me I'm going to say, since the p-value is less than a significance level, I reject the null hypothesis. So this time, if I'm rejecting the null, I'm in favor of the alternative. So I could say something as simple as there is evidence this die is unfair. I could even point out that it seems like 1 and 6 are coming up too much. Don't sound too definite. You might say it seems as though the number 1 came up too much and the number 6 came up too much. So that's why this die seems unfair. Notice that at least 2 of the outcomes seem to insinuate that the die is not fair. All right, so there's another worked out example. One more short video with another example coming up.